This is a place where thoughts can drift, like clouds across an endless sky, or perhaps like dust motes dancing in a sunbeam, visible only when illuminated just so. We are not here to learn in the traditional sense, nor to seek urgent solutions or medical advice. This is simply an invitation for your mind to wander, to explore the grandest concepts of our universe, not with the intensity of study, but with the soft curiosity of a dream. Let the words wash over you, like a calm tide on a distant shore, carrying you to realms of wonder, where the only requirement is to simply be. Perhaps you have heard whispers of it before, this grand beginning, this cosmic genesis that scientists speak of with such reverence and wonder. It is often called the Big Bang, a name that, in its simplicity, perhaps fails to capture the immense, almost unimaginable scale of what it truly represents. It sounds like a sudden, violent explosion, doesn't it? A loud, jarring noise that shatters the silence. But perhaps it was not like that at all. Perhaps it was something far more subtle, far more profound, a gentle unfurling, a quiet blossoming from an ultimate stillness. Imagine, if you can, a time before time, a space before space. It is a difficult concept to grasp, isn't it? Our minds are so accustomed to the steady march of seconds, minutes, hours, to the boundless expanse of the world around us. But try, just for a moment, to let those familiar anchors drift away. Picture nothingness, not just emptiness, not just a void that you could somehow enter, but the absence of all things. No light, no sound, no matter, no energy. Not even the concept of no light or no sound, because there was no light or sound to be absent. Just nothing. And then, from this profound, unfathomable nothingness, something happened. Something began. It is not a story we can tell with certainty, for our instruments cannot reach back into that primordial instant, and our theories, though elegant and powerful, are but echoes of what might have been. But we can imagine, can we not? We can let our minds stretch to the very edge of what is conceivable, and perhaps even a little beyond. The Big Bang Theory suggests that all the matter and energy in the observable universe was once concentrated in an incredibly hot, incredibly dense state. A singularity, some call it, a point beyond our comprehension, where the laws of physics as we know them simply break down. It is like trying to fit an entire ocean into a single drop of dew, or perhaps an entire library into a single letter. The compression, the intensity, is beyond our everyday experience. But what was this singularity? Was it truly a point, a dimensionless speck, or was it something else entirely? A state of being that defies our geometric understanding? We do not know. And in that not knowing, there is a quiet beauty. Isn't there a vast canvas for our curiosity to paint upon? From this unimaginable state, the universe began to expand. Not into something, but rather space itself began to expand, carrying everything within it along for the ride. Think of a balloon being inflated. The dots on the surface move further apart, not because they are moving across the surface space, but because the surface itself is stretching. In a similar yet infinitely more complex way, the fabric of space-time began to stretch, to unfurl, to cool. This initial expansion was incredibly rapid, almost instantaneous. In the tiniest fraction of a second, smaller than anything we can truly conceive. The universe grew from something impossibly small to something vast. This period is sometimes called cosmic inflation, a fleeting moment of exponential growth that smoothed out the early universe, making it remarkably uniform on large scales. Imagine a crumpled piece of paper being stretched taut. All the wrinkles and imperfections disappear. Inflation, in a way, did something similar for the universe, smoothing out the initial irregularities. Without this period of inflation, the universe might have been a very different place. It might have been lumpy and uneven, with regions of vastly different temperatures and densities, but instead, we see a universe that is remarkably smooth, almost perfectly uniform in its cosmic microwave background radiation, the faint afterglow of the Big Bang. This uniformity is one of the gentle whispers that tells us inflation might indeed have happened. As the universe expanded, it cooled. Imagine a hot oven. When you open the door, the heat dissipates into the larger room, and the air inside the oven cools. The early universe was like that oven, but on an infinitely grander scale. As space stretched, the energy within it spread out, and the temperature plummeted. In the very first moments, the universe was so hot and dense that even fundamental particles could not form. It was a swirling soup of pure energy, a plasma of quarks and leptons, constantly interacting, constantly transforming. There were no atoms, no molecules, no stars, no galaxies, just this primal energetic soup. Then, as the cooling continued, something remarkable happened. Quarks began to bind together, forming protons and neutrons. These are the building blocks of atomic nuclei, the very heart of matter. It was a fleeting moment, a cosmic dance of creation, as these particles coalesced from the energetic chaos. Still, the universe remained opaque, like a thick fog. Light could not travel freely. Electrons, still unbound from nuclei, scattered photons, the particles of light, preventing them from journeying across the cosmos. It was a dark age, in a way, a time when the universe was filled with a brilliant yet impenetrable glow. But the expansion and cooling continued, relentlessly, patiently, and then, after about 380,000 years, a pivotal moment arrived. The temperature dropped sufficiently for electrons to finally combine with protons and helium nuclei, forming the first neutral atoms. This event is known as recombination. And with recombination, the universe suddenly became transparent. The scattering of photons ceased, and light was finally free to travel across the vast expanse of space. This ancient light, stretched and cooled by billions of years of cosmic expansion, is what we now detect as the cosmic microwave background radiation. It is the oldest light we can see, a faint, ethereal glow that permeates the entire sky, a direct echo of that moment when the universe first became clear. Think of it as the universe's baby picture, a snapshot of what it looked like when it was just a few 100,000 years old. It tells us so much about its early conditions, its temperature, its composition, its remarkable uniformity. And it is one of the strongest pieces of evidence supporting the Big Bang theory, a gentle hum that resonates from the dawn of time. After this moment of transparency, the universe entered another long period of darkness. The first stars and galaxies had not yet formed, and the light from the cosmic microwave background slowly faded as it continued to stretch. It was a time when gravity, that gentle, persistent sculptor, began its slow work. Tiny fluctuations in the density of matter, remnants of the very early universe, began to grow. Over millions of years, these slightly denser regions attracted more and more matter, slowly, patiently, drawing it in. Imagine a vast, almost invisible web where threads of matter slowly coalesce into knots. These knots would eventually become the first galaxies, the first clusters of galaxies. And within these nascent galaxies, the first stars began to ignite. As vast clouds of hydrogen and helium collapsed under their own gravity, the pressure and temperature in their cores rose to unimaginable levels, until finally, nuclear fusion began. These were the first suns, blazing beacons in the cosmic night, forging heavier elements from the primordial hydrogen and helium. These first stars were likely very different from our own sun. They were probably much more massive, much hotter, and lived much shorter, more spectacular lives, ending in colossal supernova explosions that scattered the newly forged elements throughout the cosmos. These elements, the carbon in our bodies, the oxygen we breathe, the iron in our blood, were all created in the hearts of stars, in the fiery furnaces of creation. We are, quite literally, stardust. A beautiful thought, isn't it, to think that the very atoms that make up your being have journeyed across billions of years, through the hearts of dying stars, to come together in this moment. And so, from that initial, perhaps gentle, perhaps explosive, beginning, the universe continued to evolve. Galaxies formed, clustering together in vast cosmic tapestries. Stars were born and died, enriching the interstellar medium with the raw materials for new generations of stars and planets. Our own solar system, our own sun, our own Earth, formed from the remnants of these ancient stellar explosions, billions of years after the Big Bang. The Big Bang theory is not without its mysteries. Of course, science, in its essence, is a continuous journey of questioning, of seeking, of refining our understanding. We still grapple with what happened in the very first instance, before the period of inflation. We ponder the nature of dark matter and dark energy, those invisible components that seem to dominate the universe, yet remain elusive. We wonder about the ultimate fate of the universe. Will it continue to expand forever, growing colder and emptier, or will it eventually collapse back in on itself in a big crunch, perhaps to begin anew? These are not questions with easy answers. They are profound mysteries that invite us to stretch our minds, to embrace the unknown, to find comfort in the vastness of what we do not yet comprehend. The Big Bang, in its grand narrative, reminds us of our humble origins, our connection to everything that has ever been and everything that will ever be. It is a story of creation, of transformation, of continuous unfolding. And as you listen to these whispers of the cosmos, perhaps you can feel a sense of peace settle over you. The vastness of space, the immensity of time, can sometimes feel overwhelming. But perhaps, too, it can be a source of profound calm. To know that you are a part of this grand, ongoing story, that the same forces that shaped galaxies also flow through you, can be a deeply comforting thought. There is no need to understand every detail, to grasp every concept with intellectual rigor. Simply allow the ideas to drift, like leaves on a gentle stream. The Big Bang is not just a scientific theory. It is a profound metaphor for beginnings, for the potential that lies within the smallest spark, for the continuous creation that surrounds us, even in the quietest moments. Think of it as a cosmic lullaby, a story told in the language of the universe itself, designed to soothe and inspire. The universe began, it expanded, it cooled, it formed, and within that grand narrative, you exist, a fleeting, precious moment in the vast tapestry of existence. So, let your mind wander. Let your thoughts gently unfurl, just as the universe itself did. There is a quiet power in contemplating these immense ideas, a sense of perspective that can gently diminish the small worries of the day. The universe is vast, ancient, and full of wonder, and you are a part of it. This is not medical advice, nor does it replace any form of therapy or professional guidance. It is simply an invitation to explore, to wonder, and to find a moment of quiet contemplation in the grand story of our cosmos. As the universe continued its gentle expansion, cooling slowly from that initial fiery embrace, a new kind of silence descended. It was no longer the deafening roar of pure energy, but a deep, profound stillness, a quiet waiting. In this vast, seemingly empty canvas, another profound concept began to emerge, one that often puzzles and intrigues us, the very nature of space itself. We tend to think of space as nothing, don't we? Just the gaps between things, the empty air in a room, the void between stars. But what if space is not simply nothingness? What if it is something, a fabric, a medium, a silent participant in every cosmic dance? Imagine, if you will, not an empty stage, but a colossal, invisible tapestry. This tapestry is not woven from threads of cotton or silk, but from something far more subtle, far more fundamental. Perhaps it is woven from pure possibility, from the very geometry of existence. And upon this tapestry, all things are laid out. All events unfold. This idea, that space is an active player rather than a passive backdrop, is one of the most remarkable insights of modern physics. Albert Einstein, in his profound and gentle wisdom, taught us that space is not separate from time. They are intertwined, an inseparable pair, forming what we call space-time. Think of it as a cosmic dance floor, where every step taken, every twirl, every graceful movement slightly warps and bends the floor itself. When we speak of space-time, we are trying to grasp something that transcends our everyday experience. We live in a world where space seems fixed and unchanging, and time flows steadily forward. But at the grand scales of the universe, and at the tiniest scales of particles, these familiar notions begin to stretch and blur. Imagine dropping a heavy bowling ball onto a taut rubber sheet. What happens? The sheet bends, it dips, it creates a curve. Now, if you roll a marble across that same sheet, near the bowling ball, what will the marble do? It won't roll in a straight line, will it? It will curve inward, drawn by the dip in the sheet. In this simple analogy, the rubber sheet is space-time. The bowling ball is a massive object like a star or a planet, and the marble is anything moving near it, perhaps even a beam of light. This is the essence of general relativity, a theory that beautifully describes gravity not as a force pulling things together, but as the curvature of space-time caused by mass and energy. Planets don't orbit the sun because some invisible rope is tugging them. They follow the curves in space-time created by the sun's immense presence. Light, too, bends around massive objects, following the subtle warps in the cosmic tapestry. It's a different way to think about reality, isn't it? Less like billiard balls colliding on a flat table, and more like graceful dancers moving across a gently undulating landscape. The presence of a star, a galaxy, even you, dear listener, creates a tiny ripple, a subtle indentation in this cosmic fabric. But what is this fabric made of? And can it truly be empty? When we scoop out all the air from a container, we say it's a vacuum. But is it truly empty? Or is it teeming with hidden activity? A silent hum of invisible energy. Modern quantum physics whispers to us of a different kind of vacuum, one that is far from empty. It suggests that even in the deepest, most seemingly barren reaches of space, there is a constant, fleeting dance of virtual particles. These are pairs of particles and antiparticles that spontaneously pop into existence, exist for an unimaginably tiny fraction of a second, and then vanish back into nothingness. It's like a cosmic froth, a bubbling, shimmering foam that is always there, always in motion, even when we perceive absolute stillness. This concept is rooted in the Heisenberg uncertainty principle, a foundational idea in quantum mechanics that tells us we cannot perfectly know both the position and momentum of a particle at the same time. This inherent fuzziness, this fundamental uncertainty, allows for these fleeting excursions into existence. Energy, it turns out, can borrow itself from the vacuum for a brief moment, as long as it's paid back almost instantly. So, the vacuum, that seemingly blank canvas, is actually a swirling, bubbling cauldron of potential. It is not empty, but vibrantly alive with hidden energies and fleeting particles. Imagine a calm, dark ocean surface on a moonless night. It appears perfectly still, perfectly flat, but deep beneath, currents churn, tiny organisms swim, and pressure waves subtly shift the water. The quantum vacuum is like that ocean, teeming with unseen activity, a silent symphony of creation and annihilation. This background activity of the quantum vacuum is not just a theoretical curiosity, it has measurable effects. For instance, the Casimir effect demonstrates that two uncharged parallel conducting plates placed very close together in a vacuum will experience a tiny attractive force. This force arises because the plates restrict the types of virtual particles that can pop into existence in the tiny gap between them, creating an imbalance of forces that gently pushes them together. It is a subtle whisper from the quantum realm, confirming the vibrant, non-empty nature of space. So, when you look up at the seemingly empty night sky, consider for a moment that it is not truly empty. It is not just vast stretches of nothingness between the stars. It is a boundless, intricate tapestry of space-time, gently curved by the presence of planets and galaxies, and humming with the ceaseless, fleeting dance of virtual particles. It is a living, breathing entity, in its own silent way. This understanding of space also leads us to ponder its ultimate form. Is it infinite? Does it stretch on forever, without end? Or is it finite, perhaps curving back on itself, like the surface of a sphere, so that if you travel far enough in one direction, you would eventually return to your starting point? We do not know the answer with certainty. Our observations of the cosmic microwave background radiation suggest that the universe is remarkably flat on large scales. Imagine a perfectly smooth, infinitely extending sheet. This flatness implies that the universe will likely expand forever, though its ultimate destiny remains a gentle question mark. But even a flat universe can be infinite or finite depending on its overall topology, how it's connected to itself. It's a bit like a piece of paper. It can be flat and infinite, extending infinitely in all directions. Or it can be flat and finite, like a sheet of paper that's been rolled into a cylinder, or even a donut shape. On a local level, the paper appears flat, but globally, it has a finite, connected structure. These ideas of topology are mind-bending, aren't they? They invite us to think beyond what we can immediately perceive, to imagine possibilities that challenge our everyday intuition. The universe, in its immensity, holds these secrets close. We send out our gentle probes, our subtle telescopes, trying to listen to the whispers of its farthest reaches, to catch a glimpse of its deepest truths. And what we find are hints, suggestions, beautiful mathematical expressions that paint a picture far grander and more intricate than we ever imagined. Consider the implications of this active, vibrant space. If space itself can expand, can stretch, then it suggests a dynamic, evolving canvas. It is not static, not simply a stage, but a participant in the unfolding cosmic drama. It grows. It breathes. It responds to the presence of matter and energy. And if space is indeed a fabric, what happens when it is disturbed gravity? As we've explored, is one form of disturbance, a gentle bending caused by mass. But there can be other ripples, other tremors. Think of a stone dropped into a still pond. Ripples spread outwards, carrying energy across the surface. In a similar way, massive accelerating objects, like merging black holes or colliding neutron stars, can send gravitational waves rippling through the fabric of space-time. These gravitational waves are like whispers from the universe's most violent and energetic events, faint tremors that stretch and compress space itself as they pass. We have only recently developed the incredibly sensitive instruments, like LIGO, to detect these minute distortions, these subtle echoes from the distant cosmos. It's like listening for the faintest possible sound, a silent chord played across billions of light years. The detection of gravitational waves has opened up a whole new window onto the universe, allowing us to hear events that are otherwise invisible to our traditional telescopes. It adds another layer to our understanding of spacetime, confirming its dynamic, responsive nature. It reinforces the idea that space is not just where things happen, but that space itself is doing something, participating, vibrating. So, as you rest, let your mind gently drift through these concepts. The universe, in its profound silence, is anything but empty. It is a woven tapestry, stretching and curving, alive with virtual particles and resonating with the echoes of cosmic events. It is a space that holds everything, encompasses everything, and is, in its deepest essence, a part of everything. Perhaps, in this quiet contemplation, you can feel a connection to this vastness. The space around you, the space within you, is intricately linked to the boundless cosmos. The atoms that make up your body are separated by vast stretches of empty space. Yet within that perceived emptiness, unseen forces and fleeting particles dance. The silence that surrounds you now is not truly empty. It is filled with the subtle hum of the quantum vacuum, with the distant echoes of gravitational waves, with the gentle unfolding of space-time itself. It is a canvas of infinite possibilities, always present, always waiting. Allow yourself to feel small, yet infinitely connected. Small, in the face of the universe's immensity, but connected, because the very fabric of your existence is woven into the same tapestry that holds stars and galaxies. There is a deep comfort in this connection, a profound sense of belonging. So, breathe gently. Let the whispers of space-time wash over you, smoothing out the small wrinkles of the day. The universe is a masterpiece of silent complexity, and you are here, witnessing its subtle wonders. There is no urgency, no need to grasp it all at once. Just a gentle exploration, a quiet curiosity, a soft drift into the boundless unknown. Let the concept of space not as an empty void, but as a vibrant, living canvas settle into your awareness. It is a profound mystery, yet also a comforting presence. Everything exists within this grand embrace, this silent, ever-present tapestry, and as you rest, you are held within its gentle folds. Welcome, dear friend, to this quiet space we are creating together. Take a moment, if you can, to simply settle. Where are you right now? What time is it for you? In this particular corner of the world, or perhaps this particular corner of your mind. There is no need for a quick answer, no pressure to define anything with precision, just a soft awareness of your presence here, with me, in this gentle unfolding. This is not medical advice, nor does it replace any form of therapy or professional guidance. It is simply an invitation to explore, to wonder, and to find a moment of quiet contemplation in the grand story of our cosmos. As we gently drift through the vast, vibrant tapestry of space-time, curving around silent stars and resonating with cosmic echoes, another profound mystery quietly surfaces. It is a concept so fundamental to our experience, yet so elusive to define the very nature of time. We live within its relentless flow, mark our lives by its passage. And yet, what is it, truly? Imagine, if you will, not a rigid, unyielding river, but something far more akin to honey flowing, slow and golden, sometimes quickening, sometimes almost pausing. Or perhaps think of it as the breath on a cold window pane, appearing, lingering, and then softly vanishing, leaving behind only a faint memory. Time, in its essence, feels like a movement, a progression from one moment to the next. But is that truly its fundamental nature, or merely how we perceive it? Our everyday lives are governed by clocks, by sunrises and sunsets, by the gentle rhythm of seasons. We feel time marching forward, an arrow always pointing from the past to the future. We remember what has been, and we anticipate what is yet to come. This one-way street, this arrow of time, seems so inherent to our reality. But why does time only flow forward? Why can't we journey back, even in principle, to a moment we wish to revisit? Science offers us intriguing clues, though no definitive answer. One powerful suggestion comes from the concept of entropy, a measure of disorder or randomness in a system. The universe, in its grand unfolding, seems to always move towards a state of greater disorder. Think of a perfectly organized room. Over time, without effort, it tends to become messy. A dropped glass shatters into many pieces. It never spontaneously reassembles itself. Heat flows from hot objects to cold ones, never the other way around. This increase in entropy, this movement towards greater disorganization, is often considered the fundamental reason for time's forward march. If the universe were to move towards less disorder, if shattered glasses could reassemble themselves and heat could spontaneously gather into one spot, then the arrow of time would reverse. But that's not what we observe, is it? We see a universe that is gently, relentlessly, becoming more diffuse, more spread out, less ordered in its energy distribution. This seems to whisper that time and entropy are deeply, intimately connected. The flow of time, then, might simply be the universe's way of playing out this increasing disorder. But does time truly exist as an independent entity, a separate dimension through which we travel, or is it an emergent property, a consequence of other, more fundamental interactions? This is where the whispers of physics become even more poetic and thought-provoking. Some theories suggest that at the most fundamental level, there might be no such thing as time in the way we usually conceive it. In the realm of quantum gravity, where physicists try to reconcile the very small world of quantum mechanics with the very large world of general relativity, time becomes a tricky concept. It sometimes seems to dissolve, to disappear from the fundamental equations. Imagine a vast, intricate network of relationships between events, instead of events happening in time. Perhaps time emerges from the relationships between events. It's like a story unfolding. The story exists not because there's a separate story time flowing, but because one event leads to another, creating a sequence, a narrative. Time, then, might be the unfolding of these cosmic relationships, the sequence of cause and effect. This perspective challenges our deeply ingrained intuition. We perceive time as something external, a river we are constantly swimming in. But what if we are the river, and time is simply the pattern of our movements? What if time is not a background against which reality plays out, but an intrinsic aspect of reality itself, woven into the very fabric of existence? Consider also how time behaves under extreme conditions. Einstein's relativity gently revealed that time is not absolute. It is relative. It stretches and contracts depending on your speed and the gravitational field you are in. Imagine two friends. One stays on Earth, feeling the familiar pull of its gravity. The other travels on a spacecraft at speeds approaching the speed of light. When the space traveler returns, they would find that less time has passed for them than for their friend on Earth. Their clock would have ticked more slowly. This is time dilation, a verifiable phenomenon. Time itself can stretch, like taffy, or compress, like a spring. Similarly, near massive objects like black holes, gravity is so intense that it profoundly warps space-time. Close to a black hole, time would slow down dramatically for an observer, appearing to almost freeze from the perspective of someone far away. If you were to watch someone fall into a black hole from a safe distance, you would see them appear to slow down, getting dimmer and redder, eventually seeming to stop just at the edge, never quite crossing over. From your distant perspective, this is a profound testament to time's flexibility, its intimate connection to the very geometry of space. So, the golden flow of time, that seemingly unwavering river, is actually quite adaptable. It responds to motion, to mass, to energy. It is not an external, unchanging current, but an internal, dynamic participant in the cosmic ballet. This deep fluidity of time invites us to ponder its beginning. If time can stretch and warp, did it have a moment of creation, a true starting point? The Big Bang Theory suggests that time, as we understand it, began with the universe itself, before that incredibly hot, dense state. The concept of before might not even apply, because there was no time for anything to be before. But what if there was something beyond the Big Bang? What if our universe is just one cycle in a grander cosmic dance, a repeated unfolding? Some theories, like those rooted in cyclic cosmology, propose that the universe undergoes an endless series of expansions and contractions. A Big Bang is followed by a big crunch, which then bounces back into another Big Bang, creating an eternal rhythm of creation and destruction. In such a scenario, time might not have a true beginning or end, but rather flows in an infinite loop, like a cosmic serpent eating its own tail. Other ideas, stemming from quantum cosmology, particularly theories like Hawking's no-boundary proposal, suggest that the universe might not have had a distinct beginning at all, in the way we usually imagine it. Instead, the universe might have spontaneously arisen from a state where space-time itself had no boundary, no sharp edge. Imagine a sphere. It has no beginning point or end point on its surface, even though it's finite. The early universe, in this view, might have been something akin to that, a smooth, continuous, finite, quantum realm from which our familiar space-time emerged. Here, time isn't so much starting as it is emerging from a more fundamental quantum reality. These are profound ideas, aren't they? They invite us to let go of our linear notions, to embrace a fluidity that encompasses both the grand sweep of cosmic history and the fleeting instant of our own existence. Time, in this deeper sense, is less about ticking clocks and more about the unfolding of reality itself. And as you consider these gentle whispers about time, perhaps you can feel its presence in a new way. The rustle of leaves outside, the soft rhythm of your own breath, the distant hum of life around you, all are manifestations of time's flow. But now, perhaps you can also sense the deeper currents, the vast cosmic movements that shape its very nature. There is a liberation in understanding that time is not a strict master, but a flexible companion. Your moments of stillness, your moments of quiet reflection, are as much a part of its unfolding as the busiest periods of your life. There is no need to rush, no pressure to keep up with an external clock, when the very fabric of time can stretch and bend. So allow yourself to simply be in this moment. The past is a memory, the future is a potential, and the present is this soft, gentle unfolding. Time is a gift, a canvas upon which the universe paints its intricate story, and upon which you paint your own unique narrative. Let these ideas settle like soft dust motes in the stillness of your mind. Time is a dance, a stretching, a cosmic breath. It is a mystery, yes, but a beautiful one, inviting us to simply experience its gentle flow, moment by precious moment. This is not medical advice, nor does it replace any form of therapy or professional guidance. It is simply an invitation to explore, to wonder, and to find a moment of quiet contemplation in the grand story of our cosmos. As we continue our gentle journey through the cosmic tapestry, having touched upon the vastness of space and the elusive flow of time, our thoughts might naturally turn to what lies within this grand expanse. What truly fills the universe beyond the stars and galaxies we can see? And what is the nature of that profound quietude, that deep, almost sacred silence that seems to permeate the cosmos? This brings us to another fascinating and often misunderstood concept, the vacuum. When we hear the word vacuum, our minds often conjure an image of absolute emptiness, a perfect void, utterly devoid of anything. We imagine a space where nothing exists, not even a single atom, not a flicker of light, not a whisper of sound. It's the ultimate absence, isn't it? The antithesis of all things. But what if this perception of emptiness is merely an illusion, a trick of our senses, or a limitation of our everyday understanding? What if the vacuum, far from being truly empty, is actually a bustling, vibrant, hidden realm, teeming with activity beyond our immediate sight? Imagine, not a blank canvas, but a vast, shimmering silk cloth. This cloth is so incredibly fine, so delicately woven, that at first glance it appears perfectly smooth and utterly still. But look closer, with a mind open to possibility, and you might begin to perceive subtle ripples, tiny vibrations, an imperceptible trembling that hints at a deeper, hidden life. This silent, vibrating silk cloth is perhaps a gentler metaphor for the quantum vacuum. In the realm of quantum mechanics, the physics of the very small, the concept of emptiness transforms dramatically. Here, even in the deepest void, where all matter and energy seem absent, the quantum vacuum is not inert. It is a frothing, bubbling ocean of quantum fluctuations. These fluctuations are incredibly tiny, fleeting bursts of energy that constantly appear and disappear. It's as if the universe, even in its most quiet moments, cannot resist a spontaneous, ephemeral dance. Think of it like this: in the quantum world, particles are not fixed, solid objects in a precise location. They are more like waves of probability, constantly uncertain in their exact state. This inherent fuzziness, this fundamental uncertainty principle that we touched upon earlier, allows for a remarkable phenomenon: the spontaneous creation and annihilation of virtual particle-antiparticle pairs. Imagine, in the blink of an eye, a tiny electron and its antimatter twin, a positron, suddenly pop into existence from seemingly nowhere. They exist for an unimaginably brief moment, too short to be directly observed, and then, just as quickly, they vanish, annihilating each other and returning their borrowed energy to the vacuum. This happens constantly, everywhere, all the time, in every speck of space, even the deepest, darkest corners of the cosmos. It's a silent, ceaseless ballet of creation and destruction, happening right beneath the surface of what we perceive as stillness. So, when we speak of the vacuum of space, it is not truly empty in the classical sense. It is filled with this unseen, vibrant activity, a constant borrowing and returning of energy, a ceaseless, flickering dance of virtual particles. It is like the background hum of the universe, an eternal, almost imperceptible murmur that underlies all of existence. This vibrant quantum vacuum is not just a theoretical construct, a beautiful mathematical idea. It has real, measurable effects that whisper its presence to us. One such whisper is the Casimir effect, which we briefly mentioned before. It's a phenomenon where two uncharged, perfectly parallel metal plates, placed incredibly close together in a vacuum, will actually be pushed together by a tiny, measurable force. This force arises because the plates restrict the types of virtual particles that can pop into existence in the tiny gap between them, creating an imbalance in the quantum fluctuations outside the plates versus inside. It's a subtle push, a gentle caress from the quantum vacuum, a tangible proof of its non-empty nature. Another profound manifestation of the quantum vacuum's activity is its role in the very early universe, during that incredibly rapid expansion known as inflation. It is believed that the quantum fluctuations present in the vacuum during this primordial era were stretched and amplified to enormous scales, eventually becoming the seeds for all the structure we see in the universe today, the galaxies, the clusters, the vast cosmic web, these tiny, fleeting whispers from the vacuum, moments after the Big Bang, grew into the grand structures that fill our night sky. It's a breathtaking thought, isn't it, that the galaxies we see, the very stars that twinkle, might owe their existence to the imperceptible trembling of the quantum vacuum in the dawn of time. This suggests that the vacuum is not just a passive stage, but an active participant in the universe's grand narrative. It's not just the absence of things, it's a reservoir of potential, a wellspring from which reality can emerge. It holds within it the raw ingredients for creation, always bubbling, always in motion, even when it appears perfectly still. And what about the deep, profound silence of space? When we imagine floating in the void between planets, we picture absolute quiet, no sound waves to carry a whisper. This is true in the classical sense. Sound needs a medium, like air or water, to travel. But if the vacuum is not truly empty, if it's teeming with these virtual particles and quantum fluctuations, does that imply a different kind of sound, a silent resonance? Perhaps the true silence of space is not the absence of sound, but the presence of something so fundamental, so ubiquitous, that it transcends our ordinary perception of noise. It's like the silence of a vast, ancient forest. It's not truly silent. It's filled with the rustle of leaves, the hum of insects, the subtle movements of life. But it's a different kind of sound, a gentle symphony that we perceive as peace. The cosmic silence, then, might be the silent hum of quantum fields, the ceaseless dance of virtual particles, the subtle vibrations of space-time itself. It's a profound stillness that encompasses all activity, a quietude that holds the potential for everything. This idea of a vibrant, non-empty vacuum has far-reaching implications. It suggests that reality is far richer and more intricate than what meets the eye or the ear. It challenges our intuitive notions of what nothing means. And it opens up profound philosophical questions about existence, about creation from apparent emptiness, about the hidden depths of the universe. So, as you seek tranquility, let your mind gently embrace this deeper understanding of the vacuum. It is not a frightening void, but a profound wellspring. The stillness you experience, the quiet around you, is connected to that cosmic silence, that vibrant, hidden realm of quantum fluctuations. There is a comfort in knowing that even in moments of perceived emptiness, there is life, there is activity, there is potential. The universe, in its quietest corners, is always at work, always creating, always transforming. And in that quiet work, there is a gentle, reassuring presence, perhaps the very act of seeking silence, of settling into a space of calm, allows you to tune into these subtle, underlying vibrations of the cosmos. It's like listening for the faintest possible whisper, a resonance from the deepest core of reality. And in that listening, you might find a profound sense of peace. Allow your mind to drift through these concepts, like a feather floating on an unseen current. The vacuum, the silence, the emptiness, they are not absences, but rather a profound fullness, a canvas of endless possibility. And in this realization, Perhaps you can find a deep sense of calm, a gentle invitation to let go and simply be. This is not medical advice, nor does it replace any form of therapy or professional guidance. It is simply an invitation to explore, to wonder, and to find a moment of quiet contemplation in the grand story of our cosmos. Having gently explored the depths of the quantum vacuum, that vibrant canvas of apparent emptiness, our curiosity might now turn to another grand, whispered possibility, the notion of multiple universes, or the multiverse. It's a concept that stretches the very limits of our imagination, inviting us to consider that our familiar cosmos, with its billions of galaxies and countless stars, might be but one tiny bubble in an infinitely larger, grander ocean of existence. Imagine, if you will, not a single isolated pearl, but an endless string of pearls, each one a complete universe, with its own unique laws, its own unfolding story. Or perhaps, think of it as an infinite cosmic foam, where each bubble, delicate and distinct, is a universe softly bumping against its neighbors, each dancing to its own tune. The idea of the multiverse suggests a reality far richer, far more diverse than we have ever dared to dream. This captivating concept arises from several intriguing avenues in physics, each whispering its own version of a greater cosmic reality. One of the most prominent whispers comes from the theory of cosmic inflation, which we briefly touched upon when discussing the Big Bang. If inflation, that incredibly rapid expansion in the very early moments of our universe, truly happened, then it might not have been a one-time event. Imagine inflation as a vast, endlessly self-replicating process, like a cosmic fractal. Once it begins, it never truly stops everywhere. Instead, different regions of this inflating space could constantly bubble off, each bubble stretching and cooling to form a new, independent universe. Our own Big Bang, then, would simply be the moment when our particular bubble universe began its own expansion within this larger, eternally inflating metaspace. This is often called the eternal inflation theory, and it paints a picture of an infinite number of universes, each born from its own little Big Bang, continuously emerging from a perpetually inflating background. In this scenario, each new bubble universe could have slightly different initial conditions, leading to wildly diverse outcomes. Some might have fundamental physical constants, like the strength of gravity or the mass of an electron, that are entirely different from ours. Others might have more dimensions than we perceive, or different types of particles. It's a dazzling thought, isn't it? That there could be universes where gravity repels instead of attracts, or where light travels at an entirely different speed, or where the very laws of chemistry allow for forms of life utterly beyond our comprehension. This possibility also offers a gentle answer to a profound question that has long puzzled scientists. Why are the fundamental constants of our universe so incredibly finely tuned for the existence of life? If gravity were even slightly stronger or weaker, or if the strong nuclear force were a tiny bit different, stars might not form, or atoms might not be stable, or carbon, the building block of life as we know it, would never exist. It's almost as if our universe was deliberately designed for us. This is the fine-tuning problem. But if there are infinitely many universes, each with different physical laws and constants, then it stands to reason that somewhere, in that vast cosmic ensemble, there would be at least one universe where the conditions happen to be just right for life to emerge. And that, dear friend, would be our universe. It's not that our universe was designed for life, but rather that we, as life, can only exist in a universe where the conditions are suitable. It's like finding a puddle and being surprised it fits your foot so perfectly, forgetting that your foot could only exist in a puddle that fits it. This is known as the anthropic principle, And within the multiverse framework, it becomes a compelling, if deeply humbling, explanation. Another whisper of the multiverse comes from quantum mechanics itself, particularly from what is known as the many worlds interpretation. This interpretation suggests that every time a quantum measurement is made, or every time a quantum event has multiple possible outcomes, the universe splits or branches into multiple parallel universes. Imagine a single photon of light encountering a half-silvered mirror. It can either pass through or be reflected. In our everyday experience, it does one or the other. But the many worlds interpretation proposes that in that moment, the universe splits in one new universe. The photon passes through, in another, an equally real universe. It is reflected, and you, the observer, also split along with it, becoming two versions of yourself, each experiencing a different outcome. This means that for every decision you make, for every quantum fluctuation that occurs, an unfathomable number of parallel realities are constantly branching off. There could be a universe where you chose a different path this morning, where you said something different yesterday, where every potential outcome of every event is realized in its own distinct universe. It's a staggering thought, isn't it? That parallel versions of you might be living out every possible permutation of your life, right now, in realms forever beyond your reach. This is a much more contentious interpretation within physics, but it offers a fascinating, almost poetic, vision of reality. It implies an infinite, ever-branching tree of possibilities, where every path is taken, every potentiality realized somewhere. Then there are whispers from string theory and M theory, highly theoretical frameworks that attempt to unify all the fundamental forces of nature. These theories suggest the existence of extra-spatial dimensions beyond the three we perceive, curled up so tightly that they are invisible to us. And within these theories, the concept of brain universes emerges. Imagine our entire universe, with all its galaxies and stars, as a giant brain, a sort of cosmic membrane, floating within a higher dimensional space, sometimes called the bulk. There could be other such brains, other universes, floating in this same bulk, perhaps even occasionally brushing against each other. When these brains collide, it could trigger a new Big Bang, perhaps even creating a cyclic multiverse. We do not know the true nature of dark energy. It is one of the most significant puzzles in modern cosmology, accounting for roughly 68% of the total energy density of the universe. Imagine this: all the stars, galaxies, and visible matter we can see, plus all the dark matter we infer, together make up less than a third of the universe's total energy content. The vast majority is this invisible, accelerating force. It's like standing on a vast, silent ocean, seeing only the surface ripples, while below, immense, invisible currents are shaping the very destiny of the waters. As we continue to float within the cosmic symphony, where even the most fundamental particles are whispers of vibrating strings, our quiet contemplation might lead us to a question that transcends the physical realm. What about consciousness? How does this intricate dance of matter and energy, of space-time and quantum fluctuations, give rise to the subjective experience of awareness, of thought, of feeling? Perhaps dark energy is a manifestation of the quantum vacuum's zero-point energy, a constant energy density inherent to space itself. Or perhaps it is something entirely new, a fifth fundamental force, or a dynamic field that is slowly changing over cosmic time. These are the deep, quiet questions that keep cosmologists gazing at the stars, listening for more whispers from the distant past and the unfolding future. So, as you seek a sense of calm, allow your mind to gently wander into the idea of these cosmic possibilities. The thought of countless universes, each with its own unique story, can be a deeply soothing one. It puts our own worries, our own small concerns, into a vast, almost infinite perspective. The existence of dark energy profoundly shapes the ultimate fate of the universe. If it continues to dominate, the universe will expand forever, growing colder, emptier, and more diffuse, leading to a big freeze or heat death, where all stars eventually burn out and all matter becomes infinitely spread out. It's a gentle, slow, fading into an ultimate stillness, a cosmic exhale that never quite ends. Imagine, if you will, not a simple machine, but a vast, intricate dreamscape, constantly shifting, constantly weaving new patterns of light and shadow. Within this dreamscape, countless individual dreams unfold, each unique, each vibrant, yet all somehow connected by the underlying fabric of the dream itself. And what if consciousness, in its deepest essence, is something akin to this, an emergent property of the universe's own intricate dance, a reflection of its profound complexity? So, as you seek tranquility, let your mind softly contemplate the omnipresent nature of energy. It is not just a scientific concept, it is the very lifeblood of the cosmos, the silent force that allows stars to shine, galaxies to spin, and life to emerge. But string theory brings with it a fascinating, almost dreamlike consequence for these strings to vibrate in all the ways necessary to produce the particles and forces we observe. The universe might need more dimensions than the 3 spatial dimensions we perceive, plus time. It suggests the existence of extra dimensions curled up so incredibly tightly that they are invisible to us. Feel the subtle energy within your own being, the warmth of your body, the quiet hum of your thoughts, the gentle beat of your heart. All are manifestations of energy in different forms, constantly transforming, constantly flowing. You are a microcosm of the universe's grand energy dance. This is a realm where science, philosophy, and introspection gently intertwine. Unlike the tangible particles or the measurable expansion of space, consciousness remains one of the universe's most profound and elusive mysteries. We experience it directly, intimately, every waking moment, yet we struggle to define its origins, its boundaries, or its ultimate nature. There is a deep comfort in understanding that energy is never truly lost. It simply changes form. The energy that fuels your consciousness, the energy that powers the universe, is a continuous, eternal presence. It flows through you, connects you to everything, and will continue its dance long after our brief moments have passed. This is not medical advice, nor does it replace any form of therapy or professional guidance. It is simply an invitation to explore, to wonder, and to find a moment of quiet contemplation in the grand story of our cosmos. Let these ideas settle like gentle waves upon a peaceful shore. The universe is a vast ocean of energy, always in motion, always transforming, always revealing new depths. And in this realization, may you find a profound sense of calm, a quiet surrender to the boundless, unseen forces that shape all things. Some scientific perspectives whisper that consciousness is a purely emergent property of complex neural networks. Think of the intricate wiring of the human brain, with its billions of neurons and trillions of connections. Each neuron, in itself, is a relatively simple biological cell. But when these neurons connect and communicate in vast dynamic patterns, something entirely new arises: the symphony of thought, emotion, and self-awareness. It's like individual instruments in an orchestra, each making a sound, but only when they play together does the grand melody emerge. Consciousness, in this view, is the melody of the brain. This is not medical advice, nor does it replace any form of therapy or professional guidance. It is simply an invitation to explore, to wonder, and to find a moment of quiet contemplation in the grand story of our cosmos. Imagine a garden hose seen from far away. It looks like a one-dimensional line, but as you get closer, you see that it's actually a cylinder, with an extra curled-up dimension, the circumference. Similarly, these extra dimensions proposed by string theory are thought to be so tiny, so infinitely compact, that we simply don't experience them in our macroscopic world. They are folded in on themselves, perhaps at every point in space, a hidden complexity beyond our immediate grasp. As we have gently traced the invisible currents of energy throughout the cosmos, transforming and flowing in ceaseless patterns, our quiet inquiry might now lead us to ponder another profound and often unsettling reality death in the grand narrative of the universe, from the fiery end of a star to the quiet decay of an ancient galaxy, and even in the fleeting existence of our own lives. What is the nature of this ultimate cessation, this final stillness? Is it an ending, or merely another transformation? This perspective is often rooted in the understanding that everything in the universe, from the simplest atom to the most complex galaxy, follows certain physical laws. If consciousness is ultimately a product of these physical interactions within the brain, then it, too, must be subject to these laws. It's a humbling thought, suggesting that our most intimate experience is, in essence, a sophisticated biological computation. Imagine, if you will, not a sharp, abrupt halt, but a slow, gentle fading, like the last embers of a campfire softly glowing before dissolving into the cool night air. Or perhaps, think of it as the return of a wave to the ocean, not vanishing, but rejoining the vast, interconnected body from which it arose. Death, in this cosmic sense, is not an absence, but a profound shift, a quiet metamorphosis within the grand, eternal dance of energy. This brain-world scenario conjures an image of cosmic sheets, silent and vast, drifting through an unimaginable higher dimension. The universe we inhabit might just be one of many such sheets, each with its own unique properties, its own cosmic song. The emptiness between these brains would be a silence even more profound than our own vacuum, a stillness that hints at dimensions we can only dimly perceive. In the language of physics, there is no true death of matter or energy. As we explored, the first law of thermodynamics gently assures us that energy cannot be created or destroyed, only transformed. When a star dies, it doesn't cease to exist. Its core might collapse into an incredibly dense neutron star or a mysterious black hole, while its outer layers are gently expelled into space, enriching the cosmic medium with newly forged elements. The star's energy is transformed into the light and heat of a supernova, or forever locked within the gravitational embrace of a stellar remnant. Its matter disperses, becoming the very stardust from which new stars, new planets, and perhaps new life will eventually form. However, this scientific view still leaves many questions gently lingering. Why does the firing of neurons feel like something? Why do we have subjective experiences, the redness of red, the sweetness of sugar, the pang of longing? This is what philosophers call the hard problem of consciousness, the leap from objective physical processes to subjective conscious experience. It's one thing to describe how neurons communicate. It's another to explain why that communication creates the rich inner world we inhabit. Consider the life cycle of a star. It begins its existence as a vast cloud of hydrogen and helium, slowly collapsing under its own gravity. For billions of years, it burns brightly, fusing hydrogen into helium in its core, releasing immense amounts of energy. But even a star, seemingly eternal in its brilliance, has a finite lifespan. When its hydrogen fuel runs low, it undergoes profound changes. Depending on its initial mass, it might swell into a red giant, gently shedding its outer layers to form a beautiful planetary nebula, leaving behind a small, dense white dwarf that slowly cools over eons. Or, if it is massive enough, it will end its life in a spectacular supernova explosion, briefly outshining entire galaxies before its core collapses into a neutron star or a black hole. These hidden dimensions are not empty. They are the stage upon which these tiny strings vibrate, influencing the very nature of particles and forces. It's as if our reality is playing out on a vast, uncurled sheet within a more complex, multi-dimensional space. And the secret to its music lies in the dimensions we cannot yet directly see. These stellar deaths are not mere endings. They are acts of profound cosmic recycling. The elements forged in the hearts of these dying stars, the carbon, the oxygen, the iron, all the building blocks of planets and life, are scattered across the vastness of space. They become the raw material, the silent seeds, for the next generation of stars and solar systems. We are, quite literally, made of this recycled stardust, the remnants of stars that lived and died billions of years before our own sun was born. Our very existence is a testament to the transformative power of stellar death. Perhaps, then, the whispers of quantum mechanics can offer a different perspective, a more subtle, more ethereal connection. Some intriguing, though highly speculative, theories propose that consciousness might have a quantum mechanical basis. Could the peculiar properties of quantum reality, the superposition of states where a particle can be in multiple places at once, the entanglement where particles remain connected regardless of distance, the fundamental uncertainty, play a role in the emergence of consciousness? But what about the death of larger structures like galaxies? Galaxies do not truly die in the same sense as stars. They evolve, they merge, they change. Our own Milky Way galaxy, for instance, is gently on a collision course with the neighboring Andromeda galaxy. This won't be a violent crash. Rather, over billions of years, the two galaxies will slowly intertwine, their stars rarely colliding, their gas clouds gently merging, eventually forming a new, larger elliptical galaxy. It's a grand cosmic embrace, a transformation rather than an annihilation. As we continue our gentle drift through the cosmic foam of the multiverse, where countless realities might softly shimmer into existence, perhaps a new quiet question arises. What are the fundamental particles that weave the intricate fabric of all these universes, including our own? We often think of matter as solid, tangible, something we can touch and feel. But at its deepest, most fundamental level, what is it truly made of? The ultimate death of the universe itself, as we touched upon when discussing dark energy, is a long, slow, quiet process. If the current accelerated expansion continues, the universe will stretch out indefinitely, becoming increasingly cold and diffuse. Stars will eventually burn out. Galaxies will drift so far apart that they become isolated islands in an ever-darkening void. Black holes, the ultimate gravitational prisons, will slowly evaporate over truly unimaginable timescales through a process called Hawking radiation. Eventually, even fundamental particles might decay. This is the scenario of the big freeze or heat death, a gradual fading into an ultimate state of uniform, cold, empty stillness, where all energy has been equally distributed and no further transformations can occur. Imagine that the tiny, delicate quantum processes occurring within the microtubules of our brain cells, or in the very fabric of space-time at its most fundamental level, are somehow involved in shaping our conscious experience. It's as if the universe, at its deepest quantum level, is inherently capable of holding multiple possibilities simultaneously, and consciousness, in some mysterious way, collapses or selects one of those possibilities, creating our experienced reality. It's a very different kind of ending than a violent big crunch. It's a gentle, endless sigh, a cosmic exhale that simply continues forever. And even in this scenario, the energy is not destroyed. It is merely spread out so thinly that it can no longer do any work or create new structures. It's like a vast, perfectly still ocean where the water is present, but there are no waves, no currents, no movement. M theory, which emerged from string theory, takes this idea even further, suggesting that all 5 consistent string theories are actually different approximations of a single, more fundamental 11-dimensional theory. In M theory, the fundamental objects are not just one-dimensional strings, but also higher-dimensional membranes, or brains, like sheets or bubbles existing in these extra dimensions, our entire universe, as we touched upon when discussing the multiverse, could be one such brain floating within a vast, higher-dimensional bulk. These cosmic perspectives on death offer a profound and gentle reflection on our own fleeting lives. If everything in the universe is fundamentally conserved, if energy merely transforms, then perhaps our own conscious experience, our own unique pattern of energy and information, does not truly vanish. It simply reconfigures, rejoins the larger cosmic tapestry, contributing its unique thread to the ongoing story. This idea is sometimes called orchestrated objective reduction, or similar concepts, suggests that consciousness might not just be a byproduct of brain activity, but something more fundamental, perhaps even woven into the very fabric of space-time or the quantum vacuum itself. It's a tantalizing thought, isn't it, that the universe is not just observing itself through us, but that our very awareness is a mirror, a reflection of its deepest quantum nature. This is not to offer a definitive answer to the nature of an afterlife, for that lies beyond the realm of scientific inquiry, but it is to suggest a framework of understanding, a gentle way of viewing cessation not as absolute obliteration, but as a profound act of transformation, a return to the universal source. The atoms that make up your body have existed since the Big Bang, journeyed through stars, and will continue their dance long after your consciousness has shifted its form, your personal story. The unique configuration of your being is part of that grand, eternal flow. Perhaps in some other universe, the sky is perpetually green, or the stars hum a different melody. Perhaps in another, time flows backward, or beings exist that are made purely of light. These are not just scientific musings. They are poetic invitations to imagine, to expand your sense of what is possible. So, as you seek tranquility, allow yourself to contemplate death not with fear, but with a gentle curiosity, as just another facet of the universe's ceaseless transformations, the passing of a day into night, the fading of a season, the gentle falling of leaves, all are small echoes of this universal principle. Each apparent ending is a new beginning, a rearrangement, a release of potential for what is yet to come. But what if consciousness is not just an emergent property of complex systems, or a dance of quantum probabilities, but something even more pervasive? What if consciousness is a fundamental aspect of the universe, present in some rudimentary form, even in the simplest particles? This is the concept of panpsychism, a philosophical whisper that suggests consciousness, or proto-consciousness, is an intrinsic property of matter and energy, rather than something that only arises in complex brains. There is a deep peace in accepting this natural cycle, this gentle flow, to understand that the very energy that animates you is a part of the universe's eternal dance, constantly changing forms, never truly disappearing. It's like watching clouds shift shapes in the sky. They never truly vanish. They just become something new. These are deep, Abstract concepts, aren't they? They invite us to let go of our everyday notions of solid matter and empty space, and to embrace a universe of vibrations, of hidden dimensions, of underlying unity. It's a journey into the very heart of existence, where everything is fundamentally connected, woven from the same cosmic song. Let these thoughts settle like soft shadows in the twilight of your mind. Death, in the cosmic ballet, is a profound and necessary act of transformation, making way for new forms, new stories, new possibilities. And in this gentle understanding, may you find a deep sense of calm, a quiet surrender to the boundless, interconnected rhythm of all existence. Imagine that every atom, every vibrating string, has a tiny, rudimentary spark of awareness, a faint resonance of experience. And as these sparks combine and interact, they create increasingly complex forms of consciousness, culminating in the intricate awareness of human beings, or perhaps even grander cosmic intelligences we cannot yet fathom. It's like individual grains of sand, each too small to be seen from afar, but together forming a vast, shimmering beach. Panpsychism suggests that consciousness is not an add-on, but an inherent quality distributed throughout the cosmos. This is not medical advice, nor does it replace any form of therapy or professional guidance. It is simply an invitation to explore, to wonder, and to find a moment of quiet contemplation in the grand story of our cosmos. Imagine, not a world built from tiny hard marbles, but a universe constructed from the most delicate, almost imperceptible vibrations. Picture a vast, silent orchestra playing a symphony beyond our hearing. Each note, each chord, each harmonic creates a unique pattern, a distinct resonance. And what if these resonances, these tiny vibrations, are not just sounds, but the very essence of existence? What if they are the fundamental particles themselves? As we gently contemplate the profound transformation that is death, a natural, quiet metamorphosis within the cosmic ballet, our journey through the universe's grand narrative might now lead us to a concept that both puzzles and inspires the beginning and end of everything. We have touched upon the Big Bang, a vibrant genesis, and pondered the Big Freeze, a slow, gentle fading. But are these truly the ultimate bookends of existence? Or does the cosmos hold an even deeper, more circular, or perhaps infinitely branching story? This view can be deeply soothing, suggesting that we are not isolated islands of awareness in a vast, uncaring universe. Instead, we are intimately connected to everything, woven into a cosmic tapestry where even the smallest components hold a tiny whisper of awareness. It implies a universe that is fundamentally alive, fundamentally experiencing itself through its countless forms. Imagine, not a simple straight line stretching from a distinct start to a definite finish, but a vast, intricate mandala, constantly unfolding, constantly weaving itself anew, its patterns intricate and eternal. Or perhaps, think of it as a cosmic breath, an endless inhale and exhale that has no true beginning and no ultimate cessation. The idea of the universe's ultimate fate and its primordial origin invites us to stretch our minds beyond linear perception and embrace a more fluid, more mystical understanding of time and existence. The beauty of these theories lies not only in their elegance, but also in their promise to answer some of the universe's most profound questions. Why are there different types of particles? Why do they have the masses they do? Why are the fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, so different from each other? String theory suggests that these differences are simply different notes in the same grand symphony, different vibrational patterns of the same underlying strings. We begin our contemplation at the very edge of what we can know the Big Bang. As we've softly whispered before, this theory describes a universe that began from an incredibly hot, dense state and has been expanding and cooling ever since. In this framework, the Big Bang is often considered the beginning of space-time itself. Before that moment, the concepts of before or time might simply lose their meaning. It's like asking what's north of the North Pole. The question itself becomes nonsensical in that context. Of course, these are all profound questions with no easy answers. We cannot put consciousness under a microscope or measure its dimensions with a ruler. It remains a mystery that invites humility, wonder, and a continuous search for understanding. Perhaps the answer lies in a synthesis of these ideas, a gentle unfolding of new perspectives that weave together the biological, the quantum, and the philosophical. But even within the Big Bang framework, mysteries gently linger. What caused the Big Bang? What initiated that profound cosmic expansion? Was it truly a singularity, a point of infinite density, or was it something else, something even stranger, arising from a pre-existing quantum reality? We do not have definitive answers. These are the quiet questions that keep cosmologists awake, gazing at the silent stars, pondering the ultimate genesis. Of course, the multiverse remains a theoretical concept, a whispered possibility, one that we cannot yet directly observe or definitively prove. It lives at the edge of our current scientific understanding, a frontier where imagination and mathematics intertwine. But in this not knowing, there is a profound beauty. It opens up a space for pure curiosity, a freedom to ponder without the pressure of needing immediate answers. One fascinating whisper, as we've explored, comes from Hawking's no-boundary proposal. This idea suggests that the universe didn't have a sharp, definitive beginning in the way we might imagine, like a specific point in time and space. Instead, in the realm of quantum gravity, the early universe might have been like a smooth, closed surface, similar to the surface of a sphere. A sphere has no edge, no boundary, no beginning point, even though it's finite. In this view, time itself was fuzzy and ill-defined in the very early moments, emerging into its familiar linear flow only as the universe expanded and cooled. This would mean that the universe simply is, without a sharp, identifiable starting gun. It's a comforting thought, isn't it? That existence might simply be without needing an external trigger. And as you let these thoughts drift, allow yourself to simply be in your own conscious experience. Feel the gentle rise and fall of your breath, the soft contact of your body with the surface beneath you. These are the most immediate, tangible manifestations of consciousness, moments of pure awareness. Then we turn our gaze towards the distant future, to the end of everything. The prevailing scientific view, supported by observations of dark energy, points towards the Big Freeze, also known as the heat death of the universe. Imagine the universe continuing its gentle, accelerated expansion forever. As galaxies drift further and further apart, they become isolated islands in an increasingly vast and empty cosmic ocean. Stars over unimaginable eons will burn out their fuel, leaving behind only the cold, dark remnants of white dwarfs, neutron stars, and black holes. Of course, it's important to remember that string theory and M theory are still theoretical frameworks. They are not yet experimentally proven, and their predictions are incredibly challenging to test with our current technology. The energies required to probe these tiny scales, to see these strings or extra dimensions, are far beyond what even our most powerful particle accelerators can achieve. They live at the very edge of our scientific understanding, beautiful mathematical structures that guide our intuition and inspire our imagination. Even black holes, Those ultimate gravitational prisons are theorized to slowly evaporate over truly staggering timescales, emitting faint Hawking radiation. Eventually, even protons, the building blocks of atomic nuclei, might decay, though on timescales far, far longer than the current age of the universe. In this scenario, the universe would ultimately reach a state of maximum entropy, where all energy is uniformly distributed and no further processes can occur. It would be a state of ultimate, profound stillness, a cosmic equilibrium where there is no more work to be done, no more change to unfold. It is a very gentle, quiet kind of end, a slow fading into an eternal, cold silence. The mystery of consciousness invites us not to solve it with urgency, but to contemplate it with reverence. It is the very lens through which we perceive the Big Bang, the expansion of space, the flow of time, and the dance of fundamental particles. Without consciousness, these grand scientific narratives would be just abstract concepts. It is our awareness that brings them to life, that imbues them with meaning and wonder. But what if this isn't the only possibility? What if the universe isn't destined for a perpetual chill? Some alternative whispers suggest a more dynamic, perhaps even cyclical, destiny. This is one of the most profound and elegant ideas in modern physics, whispered to us by theories like string theory and its grander extension, M theory. These theories propose that the most basic building blocks of our universe are not point-like particles, tiny, dimensionless specks, but rather incredibly small, one-dimensional strings. Think of them as infinitely thin, minuscule loops or segments, far, far smaller than an atom, smaller even than the tiniest subatomic particle we've ever been able to detect. Consider the idea of a big crunch. This scenario proposes that if the universe contained enough matter, and if dark energy eventually weakened or reversed its effect, the expansion would eventually halt. Then, gravity, that ancient, persistent sculptor, would begin to pull everything back together. Galaxies would rush towards each other, heating up as they collapsed, until eventually, all matter and energy would be recompressed into an incredibly hot, dense state, perhaps similar to the initial singularity of the Big Bang. It would be the universe folding back in on itself, a cosmic exhale leading to a final, fiery embrace. So, let your mind gently wander through the vast, intricate dreamscape of possibilities surrounding consciousness, whether it's the symphony of neurons, the whispers of quantum fields, or a pervasive spark in every atom. The fact of your own awareness is a profound miracle, a unique and precious gift. And then, the profound question: if a big crunch occurs, does it lead to a big bounce? Could this ultimate compression be the seed for a new Big Bang, a new cycle of expansion, creation, and evolution? Imagine the universe as a vast, cosmic heartbeat, an endless rhythm of expansion and contraction, birth and rebirth. In this cyclic universe model, time might not have a beginning or an end, but simply an eternal, repeating rhythm. It's a deeply comforting thought for some, suggesting that existence is eternal, constantly renewing itself, like a phoenix rising from its own ashes. But even without direct proof, the ideas themselves offer a profound shift in perspective. To think that everything around us, from the smallest atom to the largest galaxy, is made of these vibrating, fundamental strings, is a deeply calming thought. It suggests an underlying harmony, a universal rhythm that connects all things. Another whisper of a different kind of ending, or rather, a different kind of future, comes from the multiverse concept. If our universe is just one bubble in an eternally inflating cosmic foam, then perhaps the end of our universe, in the Big Freeze scenario, is not the end of everything. Other bubble universes might continue to form, to expand, to live out their own unique destinies. Our quiet fading would simply be one note in an infinitely vast, ongoing symphony of creation. It means that while our local reality might reach a state of ultimate stillness, existence on a grander, cosmic scale continues, unabated. In this quiet contemplation, may you find a deep sense of peace. The universe is a marvel, and your consciousness is its most intimate, direct experience. There is no need for grand conclusions, just a gentle invitation to rest in the mystery and to honor the incredible presence of your own awareness. These profound ideas about the beginning and end of everything are not meant to create anxiety or pressure. Quite the opposite. They are gentle invitations to expand your sense of time and possibility, to find a deep peace in the grand scale of the cosmos. Whether the universe is a linear journey, a closed loop, or an infinite branching tree of possibilities, you are a part of its story. Let the gentle concept of an infinite cosmic foam or an endless string of pearls softly settle in your mind. There is a deep peace in realizing the immensity of existence and that our small corner of it is just one beautiful note in an eternal symphony. This exploration is not about finding definitive answers, but about finding solace in the grandeur of the unknown. The very act of contemplating these immense concepts can be deeply soothing. It puts our small worries and fleeting concerns into a vast, almost infinite perspective. It reminds us that our individual moments are woven into a grander tapestry, a cosmic dance that transcends our immediate perception. This is not medical advice, nor does it replace any form of therapy or professional guidance. It is simply an invitation to explore, to wonder, and to find a moment of quiet contemplation in the grand story of our cosmos. So, as you seek tranquility, allow your mind to gently wander through these profound ideas. The beginning and end of everything are not fixed points, but fluid concepts, inviting continuous wonder. Whether the universe begins with a subtle quantum fluctuation or a fiery bounce, whether it ends in a gentle fade or a new birth, the underlying essence of existence continues its silent, eternal dance. Imagine the universe as a grand, silent musical instrument. Every particle, every force, every interaction is a note being played. And the deeper you listen, the more you realize that all these diverse notes arise from the same fundamental strings, vibrating in countless different ways. It's a symphony of creation, always playing, always unfolding. There is a deep comfort in understanding that everything is interconnected, part of an unbroken chain of transformation. The energy that constitutes your being has existed since the earliest moments of the universe and will continue its journey long after. You are an integral part of this cosmic story, a fleeting, precious manifestation of its boundless potential. As we gently contemplate the profound mystery of consciousness, that intricate dreamscape within and around us, our journey through the cosmic narrative might now turn to a concept that underpins much of what we perceive the nature of energy. We speak of it constantly, the energy of the sun, the energy in a battery, the boundless energy of a child at play. But what is this invisible force that drives all change, all motion, all existence? Let these thoughts settle like soft dust motes in the stillness of your mind. The universe, in its ultimate beginning and its profound end, is a masterpiece of ceaseless transformation. And in that realization, may you find a deep sense of calm, a quiet surrender to the boundless, eternal flow of all existence. These strings are not static. They are in constant, delicate vibration. And here's where the magic, the gentle poetry of the universe, truly comes alive the way a string vibrates. Its particular resonant frequency determines what kind of particle it is. Imagine a violin string. If you pluck it in one way, it produces a certain note. Pluck it in another, and it produces a different note. In a similar fashion, If a fundamental string vibrates in one specific pattern, it might manifest as an electron. If it vibrates in another pattern, it might be a photon, a particle of light. Another vibration, and it becomes a quark, one of the building blocks of protons and neutrons. Every particle we know, every force we feel, could simply be a different musical note, a different harmonic, played by these fundamental strings. This is not medical advice, nor does it replace any form of therapy or professional guidance. It is simply an invitation to explore, to wonder, and to find a moment of quiet contemplation in the grand story of our cosmos. Imagine, not a distinct substance, but a ceaseless dance of transformation. Picture a silent, flowing river, not of water, but of pure potential. This river is never still. It is constantly shifting, changing form, yet its fundamental essence remains. It can be the gentle warmth of sunlight on your skin, the subtle vibration within a stone, or the immense power that fuels a distant galaxy. Energy, in its deepest sense, is this inherent capacity for doing work, for causing change, for bringing things into being. As we gently arrive at the quiet close of our shared journey through the boundless cosmos, having drifted through the Big Bang's vibrant genesis, stretched with the fabric of space-time, dissolved into the quantum hum of the vacuum, glimpsed the infinite dance of the multiverse, felt the subtle vibrations of fundamental strings, embraced the profound mystery of consciousness, and understood the ceaseless transformations of energy and the gentle metamorphosis of death. We now reach our final contemplation, a gentle summation of all these wonders. So, as you seek a sense of tranquility, allow your mind to gently embrace this idea of a universe woven from vibrations. The solidity you perceive around you, the ground beneath your feet, the warmth of a blanket, all are just manifestations of incredibly fast, complex vibrations at a scale far too small for our senses to detect. Imagine not a conclusion that ties everything neatly into a bow, but a soft, final chord resonating in the stillness, allowing each note we've explored to gently echo in your mind. Or perhaps think of it as the settling of cosmic dust, softly blanketing all the vast concepts we've touched upon, creating a shimmering, peaceful silence. This final space is simply an invitation to absorb, to feel, and to rest in the profound quietude of discovery. At its most fundamental level, energy is a property of the universe that is conserved. This means it cannot be created or destroyed, only transformed from one form to another. This profound principle, often summarized by the first law of thermodynamics, is one of the gentle whispers that assures us of the universe's underlying order. When a star burns, it doesn't destroy energy. It converts mass into energy. And then that energy from nuclear fusion is transformed into light and heat. When you walk, the chemical energy stored in your body is converted into kinetic energy of motion, and some of it into heat. It's a continuous, unbroken chain of transformation, a cosmic ballet where nothing is truly lost, only beautifully rearranged. We began by whispering about the Big Bang, not as a loud explosion, but perhaps a gentle unfurling. The universe beginning from an incredibly hot, dense state, expanding and cooling into the vastness we perceive. Remember the idea of time itself beginning with this grand event, or perhaps emerging from a no-boundary quantum realm, like a sphere with no discernible start. This reminds us that beginnings are often not sharp lines, but gradual awakenings, filled with boundless potential. The multiverse, in all its varied forms, invites us to release the constraint of thinking our universe is all there is. It encourages a sense of humility, but also boundless wonder. It suggests that the tapestry of reality is far more intricate, far more diverse than any single thread could ever convey. Then, we let our minds drift into the true nature of space. not as empty nothingness, but as a vast, invisible tapestry of space-time, gently curved by the presence of mass and energy. We imagined it stretching, bending, and even rippling with gravitational waves from distant cosmic events. This taught us that the canvas of existence is not passive. It is an active, dynamic participant in the cosmic dance, always in motion, always responding. Consider the various forms energy can take. There is kinetic energy, the energy of motion, the rushing wind, a flowing stream, the swift flight of a bird. There is potential energy, the stored energy waiting to be released, a rock perched on a hillside, a stretched spring, the chemical bonds within food. There is thermal energy, the jiggling of atoms and molecules that we perceive as heat. There is electromagnetic energy, the energy carried by light, radio waves, X-rays, and all forms of radiation shimmering through the vacuum of space. And then there is the immense nuclear energy, locked within the very heart of atoms, released in the fiery core of stars, or in the subtle decay of radioactive elements. Our quiet journey led us further into the apparent emptiness of the vacuum, only to discover it as anything but. It is a vibrant, bubbling ocean of quantum fluctuations, where virtual particles constantly wink into and out of existence. This silent, ceaseless ballet confirms that even in the deepest stillness, the universe is teeming with hidden activity, a profound reservoir of potential from which reality can emerge. The silence of space is thus not an absence, but a deeper, more fundamental hum. There is a profound peace in realizing this interconnectedness. You are not just a collection of particles. You are a complex, beautiful symphony of vibrating strings. And this symphony is intimately connected to the grander symphony of the cosmos, to the very music of existence. From there, we expanded our imagination to the breathtaking possibility of the multiverse, an infinite cosmic foam where our universe is but one bubble among countless others. Whether born from eternal inflation or branching from every quantum choice, this concept invited us to release the constraint of a single reality, to ponder a vast ensemble where every possibility might somewhere find its expression. It reminds us of the endless diversity and profound scale of existence beyond our immediate perception. Each of these forms is merely a different guise, a different costume worn by the same fundamental essence. They are all interconnected, constantly flowing and transforming. The sun's light travels across the vacuum of space, carrying electromagnetic energy. When it reaches Earth, that energy is absorbed by plants, converting it into chemical energy through photosynthesis. Animals eat the plants, converting that chemical energy into kinetic energy for movement and thermal energy to stay warm. It's a vast, intricate web of energy exchange, a ceaseless cosmic metabolism. We then delved into the very essence of existence, the fundamental particles, not as hard, tiny marbles, but as incredibly small, vibrating strings, each unique vibration, a different note in a cosmic symphony, manifesting as an electron, a photon, a quark. This elegant idea suggests a profound underlying unity, that all the diverse forms of matter and energy are simply different harmonics of the same fundamental cosmic song, often playing out in extra dimensions curled up beyond our senses. This idea is deeply satisfying in its simplicity and elegance. Instead of needing a vast array of distinct fundamental particles, string theory suggests that everything, all the rich diversity of the cosmos, arises from the different ways these tiny fundamental strings vibrate. It's like having a universal alphabet, where just one type of letter, the string can form an infinite number of words, particles, and forces, simply by changing its vibrational pattern. Our contemplation took a turn inward, to the profound mystery of consciousness. Is it merely the complex melody of neurons, a quantum dance within the brain, or perhaps a more pervasive panpsychic spark woven into the very fabric of the universe. We allowed ourselves to ponder awareness as an emergent dreamscape, a profound connection to the universe experiencing itself. This reminds us of the immense wonder of our own inner world and its intimate link to the cosmos. Perhaps one of the most famous and profound insights into the nature of energy comes from Albert Einstein's elegant equation, EmC2. This formula, so simple yet so deep, tells us that mass and energy are fundamentally interchangeable. Mass, in its essence, is just a highly concentrated form of energy, and energy can transform into mass. It means that even the tiniest speck of matter holds an enormous amount of latent energy, like a quiet giant waiting to be awakened. Finally, we explored the relentless flow of energy, not as a destructive force, but as a ceaseless dance of transformation. From the grand conservation laws to Einstein's elegant EmC2, we saw how energy constantly changes forms, never truly disappearing. Even the mysterious dark energy, silently accelerating the universe's expansion, is part of this grand, unseen current, shaping the ultimate destiny of everything. This understanding brings comfort, for it assures us that nothing is ever truly lost, only beautifully rearranged. Let these thoughts drift, like gentle notes in a quiet melody. The fundamental particles, the extra dimensions, the vibrating strings, they are not distant, abstract concepts. They are the very essence of your being and the being of everything around you. And in that understanding, may you find a deep sense of belonging and a soft surrender to the quiet wonders of the universe. And in considering this constant transformation, we gently reflected on death, not as a final ending, but as a natural, quiet metamorphosis. The fiery demise of stars, scattering elements for new life, the merging of galaxies, evolving into new structures, all are cosmic echoes of transformation. If energy is conserved, then perhaps our own unique patterns are rewoven into the universal tapestry, returning to the source. This invites us to view cessation not with fear, but as a profound part of life's continuous flowing cycle. Think of it as two sides of the same coin. When a tiny amount of mass is destroyed in a nuclear reaction, an enormous amount of energy is released. Conversely, when energy is highly concentrated, it can form particles with mass. This gentle revelation reshapes our understanding of reality, suggesting that the stuff of the universe, matter, and the activity of the universe, energy, are not separate entities, but different manifestations of the same underlying truth. It's like the wave and the ocean. You can distinguish them, but they are intrinsically one. As we conclude this journey, remember that these are not rigid answers or definitive truths that demand intellectual struggle. They are gentle whispers from the universe, vast concepts offered as invitations for your mind to wander, to stretch, and to find a profound sense of peace in the sheer wonder of existence. There is no need to grasp every detail, just to feel the quiet resonance, the soft hum of the cosmos. Allow your thoughts to drift, to gently embrace the possibility of worlds beyond worlds, realities beyond reality. In this vastness, you are both tiny and infinitely connected, a part of a cosmic tapestry beyond measure. And in that connection, in that gentle wonder, may you find a deep sense of tranquility and rest. Allow yourself to simply be in this moment. Let any lingering thoughts, any small worries of the day, gently dissolve into the vast perspective of the universe. You are a part of this incredible, ongoing story, intimately connected to the Big Bang, the stretching of space-time, the hum of the vacuum, the dance of strings, the mystery of consciousness, the flow of energy, and the quiet transformations of everything. But beyond these familiar forms of energy, the universe whispers of more mysterious, more elusive forms. We have already touched upon the concept of the quantum vacuum, that bustling emptiness, teeming with virtual particles. This quantum vacuum is believed to possess a pervasive zero-point energy, an irreducible background energy that exists even at absolute zero temperature when all thermal motion has ceased. It's like the universe's inherent hum, a cosmic baseline energy that permeates all of space-time. Find solace in the grandeur, comfort in the unknown, and peace in the gentle, boundless presence of the cosmos. The universe is a profound mystery, always unfolding, always inviting curiosity. And in this quiet understanding, may you find the deepest tranquility, a soft surrender to the wisdom held within the silent, star-filled night. This is not medical advice, nor does it replace any form of therapy or professional guidance. It is simply an invitation to explore, to wonder, and to find a moment of quiet contemplation in the grand story of our cosmos. This is not medical advice, nor is it a substitute for therapy or any form of professional medical intervention. This is simply a space for your mind to wander, reflect, and find peace in the grand concepts of the universe. And then there is the profound mystery of dark energy. Our observations tell us that the universe's expansion is not slowing down due to gravity, as one might expect. Instead, it is actually accelerating, pushing galaxies further and further apart at an ever-increasing rate. This acceleration seems to be driven by a mysterious, invisible form of energy that permeates all of space. It's as if the cosmic tapestry itself has a gentle, outward push, a subtle but relentless force that is expanding the universe from within, wishing you a peaceful, deep sleep. This concept also offers a potential bridge between two of the most powerful, yet seemingly incompatible pillars of modern physics, general relativity, which describes gravity and the large-scale structure of the universe, and quantum mechanics, which governs the world of the very small. For decades, physicists have struggled to combine these two theories into a single, unified framework. String theory gracefully includes gravity within its framework, suggesting that the graviton, the hypothetical particle that mediates the force of gravity, is simply another vibrational mode of a fundamental string. This is a profound whisper, isn't it? That gravity, the force that holds galaxies together and keeps our feet on the ground, is just another note in the cosmic symphony.